Okay, trying to do this little video while monitoring my goofballs in 6 hour, whether they're working or not, and talking about math, not English. We're talking with their friends and group intermingling, so on and so forth. Hope you can hear me, by the way, as I go in and out. So, I think what's smart on number 17 is to actually figure out if there was one processor and only one. How much time would it take for them to do this task? And basically be the sum of all the minutes, because the idea is they'd have to do every task one at a time, blah, 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 blah. So this is the maximum it would take, and that's if there was one processor. Adding up, hopefully I added that up correctly. Wasn't really asked in the question, but I just thought I'd share that. The critical time comes from finding all sources to sinks, sources to sink, source to sink, source to sink, and then finding out which one is the largest. And that is when we go from T4 to T5 to T6 to T8. So this one ends up being the largest one. Whoops, that's a mishap. Of those numbers, that's not a good color. And that ends up adding up to 85 minutes, I hope. 9, 10, yeah, it looks good. That is the minimum, even though that's the largest maximal path. That is the minimum no matter how many processors would be on the task itself. So we've talked about that before. Now, in order to construct this Gantt chart, you really have to probably have this drawn so you know what your options are to start even though we're doing at first an increasing time, which means select the lowest to the highest. But only these tasks are available to begin with. I can't start with this task because this requires or has precedence relations that these have to be done before I do any of these others. So to construct a Gantt chart with processor 1 and 2 involved, I'm going to put them like this. I'm going to put a bar here too. I don't know if I could stay straight in my old age here. Our time that we get out of this is going to be between these two. Right, so how would I create a working chart that has a scale? I don't know. I think I like going by 20s, so I'm going to say this is 120. I bet you we get under 120. I'm going to cut in half, make this 60. And then if I cut that in half, that'd be 30, then 15. I'm going to try to cut this in thirds. I kind of like that. 20, 40. At least I have a reference then. And I don't know if this is going to work out, but we'll see. And then when I create the bars for this, this will be in reference to this chart, and the bars may or may not be large enough, but we'll see. Numbers are 9's the smallest, so 9 can kind of relatively be put in here. But really what you should mark is, as I do each processor, how far are they? You should mark the minutes on each case in relation to each other. So, increasing time, we pick the smallest of the ready tasks. The smallest of the ready task is T4. So, processor 1 is going to do 11 minutes doing T4. And that's a little bit more than 10. I could cut this in half maybe again and know that that's 11. So they're going to do T4. Let's see how we put that. We could put it, we could put T4 here, and then the minutes is in the graph. So T4 is done, or is being done, and it's going to take them 11 minutes. Well, then processor 2 has not T5 available because this is still in action. So we have to look at some other tasks that are available. And the only one are those 3 sources. The next smallest one is T7. So processor 2 will be assigned T7, and that is 15 minutes. So that's approximately right here. We're at 15 minutes right here. And this is T7. And I'm going to check it off. If you don't write this down, then you don't have a chance to check off and actually have an idea of who's ready and who's not. So T4 will be done in the middle of T7 being completed by processor 2. So what happens, maybe you want to do this. This is done now, and that activates T5. T5 is now an available task along with T1 and T9. So that's what you have to understand. In 11 minutes, T4 is done while T7 is being done. Now T5 is an open task and ready to be done. T2 is not, well, actually, none of these are because none of these have been activated. And T6 is not because there's two requirements, first of all, and second of all, this one's still going as processor 1 is working. So, processor 1 has one of these three options. The smallest one is T9, which is another 16 minutes added to 11. So this is 11 minutes, and then we're going to add 16. So that's, what's 16 plus 11? Last time I checked, that's 27. So you want to make that happen kind of looking like that. And then that's T5. Oh, wrong. I looked at the wrong thing. That is T9 being done. So now T9 is done, and that's another 16 minutes. So maybe mark that right there. And T7 was 15 minutes. Maybe put the numbers below. Okay, so this person is at 27 minutes right now. And maybe make the note to self so that you know what's happening with processor 2 now. So T9 is being done, but it's not finished yet when T7 is finished. So now T7 is finished right about here. So now what that activates is, no it doesn't. T6 is not activated because T6 has this precedence requirement as well. So the open tasks that are available are T5 or T1. Okay, so between, let me make sure I got this right here. Yes, so then in between T5 and T1, T5, again doing an increasing, is smaller. So now T5 is 17 minutes. 17 plus 15 is 32. So we're a little bit past there. Right, so again, I have this scale up here to kind of get in relative terms where these two processors are in relation to each other. So now task 5 is being done. In the middle of task 5 being done but not finished, task 9 is done. But that doesn't do a whole lot because that doesn't mean task 8 is open because it has those precedence requirements as well. So now the only task that is open, and sorry I did T5, so I checked that off, done, or working on. Doing these lines actually says that these tasks are done now at the position that I'm at in this little situation. So now looking at this person is open, this processor, and there's only one task available because of precedence relationships. So now we have to do T1, which is at 20 minutes. So that gives me 47 minutes total, which is somewhere around here. So this is T1, another 20 minutes, making sure my math is correct, putting these up, and then understanding that this is now 47 minutes. These are things you might want to mark as you're going along with this. Well, the problem with this is, so this is done, or being done, and while this is being done, processor 2 gets done with task 5. So now that they're done with task 5 in this process right here, at 32 minutes, this opens up T6, because now T6's precedence relations are taken care of. So now we can assign processor 2 T6, and that is going to be 22 minutes added to 32. Oh, here we go with my math. With the crazy clowns in class getting louder and louder in here, I think that's, let me hold off. 54 minutes. That's 22 plus 32. And that is T6 being done. So as T6 is completed, T1 is completed. So now T1's completed here while task 6 is being done by processor 2. With that being completed, processor 1 opened up task 2. So now they're able to do task 2, which is 12 minutes, 47, 57, 59 minutes, right before 60. There's task 2 being done. While task 2 is being done, task 6 gets completed. Once task 6 is completed, unfortunately, task 8 is not open because it has a precedence relationship. It needs T3 to be done before we can actually do that. So here lies the issue of, having idle time. When task 6 is done and while task 2 is being done by processor 1, no other tasks are open. This has to be completed before we can do T3, which leads to T8. So the problem with this is this processor is now idle for this amount of time. So this is why I was marking down these times here. This one was 22, 32, so this was a 54-minute total at this point. And this one was 59 minutes total, which we did talk about T2 being 12 minutes. Okay, had to yell. Okay, so as of right now, we have 5 minutes of downtime, idle time. But then as we see this, once T2 is done, then we have to do T3, then we have to do T8 in that order. At this point, I couldn't care less who you assign these other tasks on the test. It doesn't matter. They could be assigned, and because we have to do T3 before we do T8, one of the processors are going to take this the rest of the way home. So in the key, they have it given to processor 1. I couldn't care less if you gave the rest of the tasks. Oh, I screwed up my, as far as how many minutes this is. At 59, here's another 9 minutes. I don't know, I think that's too long. And then another 35. I don't know. I'm just going to add those up at the end as far as the bar is concerned. Because I'm fighting students. I'm fighting trying to do this. I asked them to be quiet, and all they did is get louder. They don't care. They run the class. I don't. No respect whatsoever. I feel like Rodney Dangerfield. I don't even know if you know who that is. So anyway, T3 takes 9 minutes and then 35 minutes for T8. Basically, you just have to add those to 59 because that's where we're at right now in this whole thing. Make those bars better. I just can't concentrate with these goofballs doing what they're doing. So the total amount of time that this takes for these two processors assigned is 59 plus 9 plus 35. Which is 103 minutes. So actually, watch this. Wish you had this option, right? Yeehaw. There, now my bar works, even though this is all discombobulated. There's 103 on the graph. All right? So, to answer these questions down at the bottom, I already did one of them. Is this schedule optimal? Well, guess what you have to find out if the schedule's optimal, my little friends? You have to find the critical time, which we did do. The critical time is the minimum time that this could get done. And is this optimal? No, because this doesn't equal 85. So no, critical time equals 85. Our time equals 103, not optimal. Write this in complete sentences. I don't have the time to do that. Now, how much time are processors idle? We're idle here for 5 minutes, but then we're also idle here for the 35 and the 9 minutes for one of the two processors to do the rest of the tasks. So they're idle those many minutes, which is 49 minutes total. Now in the next video that I'm going to do without students in here, because it's the only way I can do it successfully, you'll see if we change the way we do this, it will change the time. It may be better or may be worse. That's the idea of doing an increasing or a decreasing. One might be better than the other.